Hello you two, welcome to our second video here for locus in the parabola. We're looking at the geometric definition of the parabola. Let's get straight into this. Geometric definition of a parabola is the locus of all points equidistant from a given point and a given line. So if I have a point and a line and I choose everything that is equidistant from the two of them, I'll arrive at a parabola. Now, that doesn't have to be the y equals x squared looking parabola that we've always had before. That's concave up, it could be concave down, but it can be sideways as well. We're going to see those in a moment. So let's draw a little diagram here. There's some definitions. A diagram is going to make sense of these, I think. So I'm going to start by drawing a parabola here like this, hopefully. Okay, not perfect, but it's okay. I have a parabola here. It has an axis of symmetry. So far, nothing terribly new here. But I also have, somewhere down here, a line that is perpendicular to the axis of symmetry. That's going to be my directrix. Okay, let's just label it as such. Directrix. Rightio. Now my parabola is always going to sort of curve away from that directrix. Now this distance, my parabola is halfway between the directrix and a point, so I've got this distance here, go the same distance up here, and this will be my focus. Right, that's my focus. And this here is my vertex. So I'm going to switch colours here just to label a couple of things. Now, the distance from the focus to the vertex is called the focal length. Right, we call it A. And from the vertex to the directrix is also equal to A. Right, that's our focal length, one focal length. If I were to draw a horizontal line, I'm going to give that a crack here. Let's try it in black. A horizontal line perpendicular to the axis of symmetry. A chord, in fact, that starts and ends on my parabola. Oh, this is looking a bit risky. Anyway, let's see how we go. All right, there's my chord. That's going to go from here to here. It should be a line that is a straight line through the focus and perpendicular to the axis of symmetry, or parallel to the directrix. And that line is called the latus rectum. Now, if we consider that the distance from this end of the latus rectum, where I'm indicating here with my pen, the distance from here down to the directrix should be twice the focal length, 2a. Then the distance from that end of the latus rectum back to the focus, right, should also be 2a. Switch colours here. So the full length of my latus rectum, because of the symmetry of my parabola, right, the length of my latus rectum is 4a. There we go. And that's most of this new language that belongs to a parabola. We're going to scroll down now and push on to a couple of examples, see what we can do with this information. Now I have a parabola with a focus 0, 2 and a directrix of y equals -2. Y equals -2 is a horizontal line. That means my axis of symmetry will be vertical. Right, let's get in there and start drawing these things. So my horizontal line, y equals -2. Let's see if I can change some colours here. No, it's not working very well. I'm going to draw my that's going to be my y-axis, and my x-axis here like this. Okay, I've got my directrix, and we know that the focus is at 0, 2. Put a 2 here, -2 here. Right, that means that my vertex should be exactly halfway between my directrix and my focus, which is here at the origin. So my parabola will curve away from the directrix, up here like this, and around here like this. Oh dear. Now, it's not impossible that you might be that you could lose marks for not drawing a neat enough parabola. You can see I would be losing marks here. After a certain amount of marking around, here I am again with a very scruffy looking parabola, but nonetheless, we have, as described, a focus 0, 2, a directrix of y equals -2. Now we can see that the vertex, right, as required here in the question, that the vertex is at, I'm just going to write under here, at the origin. The focal length is 2, right, 2 units, from -2 to the origin, or from the origin to 0, 2, or half of the distance between the focus and the directrix. So my focal length is 2. The length of the latus rectum is 4 times the focal length, so 4 2s is 8. If I wanted the coordinates of the endpoints of the latus rectum, it's going to be at 4, 2 and -4, 2. They're going to be my two ends. Not that the question asks for that. Not this one anyway. Now, my parabola can adopt a few different forms, right? It can be of the x squared equals 4ay, meaning it's sort of concave up, right? Concave up, x squared equals 4ay, both the x squared and the y terms have positive coefficients. It could be x squared minus 4ay, concave down, where the y term has a negative coefficient, the x squared term is positive. I could have y squared equals 4ax, which is like concave right, if you like. When it's y squared, it's sort of going sideways, right? And y squared equals -4ax is concave left, if you like. So, taking all of those into account, right, we can write them in these forms when, right, that x squared equals 4ay or equivalent, right, that form works when the vertex is at the origin. So example 4 here asks us to sketch the parabola x squared equals -12y. That's going to be concave down. Okay, it's of the form x squared equals negative something y, so concave down, showing the focus, directrix, and endpoints of the latus rectum. So let's get to drawing this. My sketches recently have been less than perfect. We'll have a go. So I said it was going to be concave down. There is a concave down parabola. Now I'm going to have a directrix up here somewhere, a focus here somewhere. Now we have because there are no brackets here, my vertex is at the origin. Okay, not quite perfectly drawn there. Vertex at the origin there, x and y axes. Right, so it's something like this. Now, if x squared equals 4ay, oops, equals -12y, and x squared equals 4ay, then 4a is, oops, is -12, and a is -3. So my focal length is -3. So that means this here must be at 3. My directrix is y equals 3, and my focus is down here at 0, -3. I've just realized that that's probably going to be an issue, having written it like that, because I need to draw my latus rectum in. Right, that is so messy. Your diagrams, can I stress, should be much better than this. It's just me drawing badly on my graphics tablet. So from 0, -3, I need to go twice the focal length over here to the left. Right, so from 0, my focal length is 3, or -3 perhaps. So I'll go twice that over here, which will be, so this is going to be at -6. -3 is one endpoint. and over here is 6, -3. Okay, is that what we want? We've got the focus, the directrix, and the endpoints of the lattice rectum. Rightio. And finally, one more here. Write down the equation of the parabola with the vertex at the origin and a directrix of x equals 2. Now, x equals 2 is a vertical line. So, I have, over here somewhere, let's draw a little sketch. These things must start with a sketch. Okay, so my x and y axes, and x equals 2, that's 2. There's my directrix. So my parabola then, with the vertex at the origin, right, must be doing this. Okay, it's doing this. Right, so that means that I'm in the form of, so concave left there, is something like y squared equals -4ax. That's the general form. Now a, we can read off here, is the distance from the directrix to the vertex. So a equals 2, therefore we have y squared equals -8x. Right? That is the equation of the parabola with the vertex at the origin and directrix x equals 2. And I think that's going to be it. That is indeed it for this video. So coming back to these things, a couple of terms, some new language we learned here. Focus and directrix. Right? Focus is a point and a directrix is a straight line. And a parabola is always equidistant between that straight line directrix and point, the focus. The focal length is the distance from the vertex to the directrix or the vertex to the focal point. The latus rectum is a chord perpendicular to the axis of symmetry, parallel to the directrix, passing through the focus. And the length of the latus rectum is 4 times the focal length. Rightio. They're the main things here for this exercise 11b. I hope that's helpful. If you have some questions, certainly jot them down. Ask me in class. I'll see you there.